Hello everyone, welcome to MSD, the online classes. So in the previous session we have discussed about the factor theorem, its statements as well as some applications of factor theorem. And today in this class we will discuss about wide applications of factor theorem. We will basically discuss about three type of question or three type of problems that will have been asked in your examination. Okay, so let us start with the first type. The type first is known as type 1 question. Okay, this type of question must be asked in your examination. So let us come with the first question. First question we have, check whether 7 plus 3x is a factor of 3x cube plus 7x. So we have to check whether this polynomial is a factor of this polynomial. Okay, so we have to first write what we have. We have p of x is equal to 3x cube plus 7x, and we have also the divisor g of x. And what we are going to find, we have to show or we have to verify or check whether this polynomial is a factor of other polynomial. According to the statement 2 of the factor theorem, we studied here that x minus a will be a factor if and only if p of a is equal to 0. Okay, we have studied about it. It is the second statement of factor theorem which describes that if p of a is equal to 0, p of a means remainder. Okay, so if remainder is equal to 0, then we can say x minus a is a factor. Okay, so the only condition we have to find out the value of the remainder. So in this problem, if we can see or if we can show or prove the remainder to be 0, then we can say yes, this one is the factor of the other polynomial. Okay, so our task is to find the value of the remainder, and we have to show whether the remainder is 0 or not 0. If it is 0, then it will be a factor. If the remainder is not 0, then it is not a factor. Okay, so we have to first find out the value of the remainder. But before finding out the value of remainder, we need a. Okay, we need a here. A means 0 of this polynomial. Okay, or it is known as root of this polynomial. Okay, how can we find out the root? As from the remainder theorem we know how can we find out the root? By simply putting this divisor to be 0 is equal to 0. Okay, then we can get 3x is equal to minus 7. Okay, and x is equal to minus 7 by 3. So here we get x is equal to minus 7 by 3. This is nothing but the 0 of the polynomial. Okay, this is also known as a, or you can say it as root of the polynomial or root of the divisor. So our first task to find the value of a has been completed. Now we will find the value of the remainder. Since we have p of x is 3x cube plus 7x. Okay, and now we will find the remainder. So in place of x, we are going to put minus 7 by 3. So the polynomial will be whole cube. Okay, this is a curly bracket plus 7 whole into minus 7 by 3. While calculating the terms, you must be careful. 3 into minus 7 divided by 3 whole to the power 3. That means minus 7 is multiplied 3i's, 3 also multiplied 3i's. When minus 7 multiplied 3i's, so it will be, since minus is multiplied odd number of times, so the answer is minus. When 7 is multiplied 3i's, our answer is 343. Divided by 3 is multiplied 3i's means 27. Okay, then plus 7 into 7 is minus 49 by 3. Okay, then you can cancel out 3 1 3 9. So it will be minus 343 by 9 plus minus is minus 49 by 3. Okay. So now 9 3 LCM is 9 minus 343 minus 9 3 divided is 3. 3 into 49. It will be 157. So since there is same sign, so they must be added, and after addition it will give 500 minus 500 divided by 9. So what we will get after putting the value x in the polynomial? We get the remainder, that is p of minus 7 by 3 is equal to minus 500 by 9. Okay. So did we get the value of the remainder to be 0? No, we didn't get p of minus 7 by 3 to be 0. We didn't get it. That's why we can say no, this is not a factor of this polynomial. If we can show it to be 0, then we can say yes, it is a factor. But here we didn't get 0 as a remainder. Then we can say no, 7 plus 3x is not a factor. Okay, not a factor of 3x cube plus 7x. Okay, this is clear. Now coming to the second question. The second question is also similar to the question 1. Okay, the second question what we have, see, we have x minus 3. We have to show x minus 3 is a factor of x cube minus 4x square plus x plus 6. So what we have? We have p of x is equal to x cube minus 4x square plus x plus 6. Okay, and g of x, or the divisor, will be x minus 3. So we have to verify, we have to examine whether this is a factor of this polynomial. Similarly, according to the factor theorem, x minus a is a factor. What is the condition? If the remainder p of a is equal to 0. That means if we can show p of a is equal to 0, then we can say yes, x minus a is a factor. Similarly, in this condition or in this problem, first we have to show whether the remainder to be 0 or it is not equal to 0. If it is 0, then it is true that it is a factor. If it is not 0, then it is not a factor. So let us find out the value of the remainder. But in order to find out the value of the remainder, we need the value of the 0, or we need a, okay, or we need x, whatever you can say. So we need the value of a here. So in order to find the value of a, how can we find it? By putting the divisor to be 0. Okay, so you can write putting x minus 3 is equal to 0, then we get x is equal to 3. Okay, so this is the 0 of divisor, or 0 of the polynomial, or you can say it as a. So we get a is equal to 3. Now we are going to find the remainder. Since remainder is written in the form p of a, but what we have, the polynomial p of x is x cube minus 4x square plus x plus 6. So in place of x, we will put 3. So it will be 3 cube minus 4, 3 square plus 3 plus 6. Okay. Now 3 to the power 3 is 27 minus. See here, 3 to the power 2 is 9, and 4 into 9 is 36, plus 3 plus 6 is 9. Now 27 minus 36 is minus 9. Okay, because the negative sign placed before the greater number or larger number, plus 9. Different sign means there can be subtracted. 9 minus 9 is 0. So this is our final result. So we can say yes, remainder p of 3 is equal to 0. So now compare it with the statement 2 of the factor theorem. The factor theorem states that if P of something or P of A is equal to 0, then x minus A is a factor. Since we have also showed that, or we have also verified that P of 3 is 0, that means we can say yes, this is a factor. Okay, so we can write yes, x minus 3 is a factor of x cube minus 4x square plus x plus 6. Okay, understood? So these are the two basic type of question of type 1 where you have to check or verify or examine whether some polynomial is a factor of other polynomial using the statement 2 of factor theorem. Okay, how? By simply showing whether the remainder is equal to 0 or not. If the remainder is equal to 0, then you can say yes, the previous polynomial is a factor of other polynomial. If it is not 0, then it is not a factor. Okay. Coming to the second type of question, that is type 2. In type 2, we have two questions to be solved. Okay. So let's do the first question. The first question we have, if 3 is a root or 0 of the polynomial, then find the factor of P of x. Okay. Again, if 3 is a root or 0. So what we have given? We have given the 0 of the polynomial or the root of the polynomial is equal to 3. Okay. So then we have to find the factor of P of x. Okay. So we need to find the factor of P of x. So before starting the problem, let's remind one thing. What is the meaning of 0? As we have discussed, the value of 0 or the meaning of 0 is the value of the variable for which the total polynomial is equal to 0. Again I am saying, what is the meaning of 0? The meaning of 0 is the value of the variable. Here variable is x, so the value of the variable, okay, this is 0, for which the total polynomial, here the total polynomial is P of x is equal to 0. This is the definition of 0. The value of the variable for which the total polynomial is 0. That means this is the 0 that is given here. So we can write it as x. Since 0 is also known as a, we can write it as a. Now, so this is the meaning of 0. So the total polynomial is equal to 0 when if x is equal to 3. This is given in the question. Okay. So according to the question, 3 is the root. That means after substituting 3 in the place of x, we will get 0 or the value of the total polynomial to be 0. Now it is clear? Okay. Now, since P of some polynomial or P of x is equal to 0, this is nothing but P of x. So what is given? It is given that the value of the polynomial is equal to 0 for x is equal to 3. Let's compare this with this equation. This equation is nothing but the equation of the remainder. Okay. Remind it. This is the remainder because P of a is equal to 0 or P of a is known as the remainder of the polynomial. But here the remainder is equal to 0 given. Okay, now remember the statement 2 of the factor theorem. What it says? It says if P of a is equal to 0, then x minus a is the factor. This is the factor theorem states that. So here we get for x is equal to 3, P of 3 is equal to 0. That means it satisfies the second statement of factor theorem. That means it satisfies this term or this statement. Then what is happening? So then we can write yes, x minus a is a factor. Okay. So here what we have? A is equal to 3. Okay. So then we can write. So the factor will be, and the factor will be x minus a, because here we have P of 3 is equal to 0. That is the remainder is equal to 0. Okay. So x minus a. Now in the place of a you can put 3. This is the factor. Hence we have the factor that is demanded in the question. So if 3 is the root, or root means a, root means x, then what is the factor? Okay, so we can get the factor is x minus 3. Okay, so this is clear. Now coming to question number 2. Question number 2 is also same or similar type of question with question number 1. In question number 2, what do we have? We have the 0. 0 means a, or you can say x. Okay, so 0 is equal to a is equal to minus 5 by 3. Okay, as we know, what is the meaning of 0? The meaning of 0 is the value of the variable, okay, for which the total polynomial is equal to 0. When this is equal to 0? For p of minus 5 by 3 it is equal to 0. That means it is the remainder part. Hence we get the remainder is equal to 0. And according to the statement 2, if the remainder, okay, if the remainder is equal to 0, then the factor is x minus a. Similarly, here we have a is given and the remainder is equal to 0. Then you can write, hence the factor is equal to x minus a. Okay, so x minus, in the place of a you can put minus 5 by 3. Okay, so it will be x plus 5 by 3. So this is the factor of the polynomial p of x. Okay, now suppose we have one more question. If minus root 2, okay, is the 0 of the polynomial, then find the factor of p of x. So directly you have written here what is given? A is given, root means a, okay, and it means the value of the total polynomial is equal to 0. That means p of total polynomial is equal to 0. That means p of minus root 2 is equal to 0. Okay, so it is nothing but the remainder is equal to 0. Okay, and we know if the remainder is equal to 0, then the factor is x minus a, and here the value of a is minus root 2. So it is written as minus plus, hence the factor is x plus root 2. Okay, so in this 3 question we can easily find out the factor if the root is given. If the root is 1, that means a is 1, then what is the factor? The factor is x minus 1. Okay, if the root is minus 5, then what is the factor? Then the factor is written as x minus a, that is x minus of minus 5, that is x plus 5. Okay, if the root is 13, okay, then what is the factor? Then the factor is written as x minus a, that is x minus 13. Okay, so if the root is given, then we can calculate the value of the factor. Clear? Let us come to the third type, that is type 3. Here we will discuss the type of question that has been asked in the examination. First, we have to discuss about the question number 1. In question number 1, what we have? It is given that find the value of k. Okay, what is k? I am first clarifying you that k is nothing but a constant. Okay, so we need to find the value of k. Okay, if x minus 1 is a factor of this polynomial. Okay, first write down what it has given in the question. In the question, what we have? We have p of x is equal to 4x cube plus 3x square minus 4x plus k. Okay, this is nothing but the dividend. And the second thing what we have, the g of x, that is the divisor. Now it is clear. Now the question asking us to find the value of k. Okay, again read the question carefully. If x minus, it is given that x minus 1 is a factor of this polynomial. That means this polynomial is a factor of this polynomial. And we know if some number or if some polynomial is a factor of other polynomial, then it completely divides the other polynomial. Okay, let us take an example. Suppose this is 6 and this is 18. That means 18 is divided by 6. First find out the factors of 18. 1, 2, 3, 6, 9 and 18. These are the factors. And 18 is divided by 6. And you can see 6 is a factor of 18. That means when 6 is a factor of 18 and it divides, or 18 is divided by 6, then what is the value of the remainder? Let us find out. 6 3 are 18. And we see the remainder is equal to 0. Then we can say if 6 is a factor of 8 or factor of 18, then 6 completely divides 18. And if it completely divides 18, it means the remainder must be 0. It is similar to this question. Here also this is a factor of this polynomial. That means since it is a factor of this polynomial, that means it completely divides the other polynomial. And if it completely divides the other polynomial, then we can say, in this case, we can say the remainder must be 0. Okay, the remainder must be 0. The remainder is written in the form P of A. That means ultimately the question given to us is P of A is equal to 0. Now it is clear, P of A is equal to 0. Or you can compare this question with the statement 1. In the statement 1 of factor theorem, it is said that if some polynomial is a factor of other polynomial, that means if x minus a is a factor of p of x, then p of a is equal to 0. This is the first statement of factor theorem. So similarly, we get the value of the remainder to be 0. Now we need to find the value of remainder. So for remainder, we need the value of a. How can we get the value of a? A is nothing but the 0 of the polynomial. How can we get a? As you know, we can get the value of the 0 or get the value of the polynomial or get the value of a by simply putting the divisor x minus 1 to be 0. So here we get x is equal to 1, and this is also known as a. Okay, hence what we get? We get a is equal to 1. Okay, it is clear. Since it is given that p of a is equal to 0, that means p of, in the place of a you can put 1 is equal to 0. It means the polynomial value is equal to 0 for x is equal to 1. Since it is given that the polynomial is 4x cubed plus 3x square minus 4x plus k is equal to 0. So in place of x, we need to put 1. So 4 into 1 cube plus 3 into 1 square minus 4 into 1 plus k is equal to 0. So 4 into 1 cube means 4 into 1, 4. 1 square is 1, 3 into 1, 3, minus 4 plus k is equal to 0. Hence 4 plus 3 is 7 minus 4 plus k is equal to 0. And 7 minus 4 is 3. So 3 plus k is equal to 0. Implies k is equal to minus 3. So here we get the value of k. Okay. So in this type of question, we can find the value of k by putting the remainder to be 0. Okay. But for that, we need to find the value of a, and in place of a, we can put the value and get the result of k. Okay. So this is a question which is related to statement 1 of the factor theorem. Now coming to the second question of this type, In the second question, what we have? In the second question, we have P of x is equal to x square plus x plus k. Okay, and g of x is equal to x plus 2. And it is given that x plus 2 is a factor of this. That means this polynomial is a factor of total polynomial p of x. And we know if some polynomial is a factor of other polynomial, then it completely divides the other polynomial. That means x plus 2 completely divides x square plus x plus k. And if it completely divides other polynomial, then the remainder will be 0. Okay? Then we can say the remainder p of a is equal to 0. Okay? It is clear? Now we need to find the value of the remainder. But in order to find remainder, we need to find a. How can we find a? You can find a by simply putting the divisor to be 0. Okay? Hence x is equal to minus 2. This is nothing but value of a. Okay? So you can write p of a is minus 2. Minus 2 is equal to 0. Since you know that the polynomial p of x is equal to x square plus x plus k is equal to 0. Okay? So in the place of x, we have to put minus 2. Minus 2 plus k is equal to 0. Minus 2 square is 4. Plus minus minus 2 plus k is equal to 0. 4 minus 2 is 2 plus k is equal to 0. Hence we get k is equal to minus 2. Okay. This is the ultimate result that is the question asking us to find. So by using this procedure or by using the statement 1 of the factor theorem, you can find the value of the constant k. Okay, because here k is nothing but a constant. So this is the process you can follow. Let us do with one more question. It is also similar type of question. Suppose we need to find the value of k. If x minus 3 is a factor of x square minus root 2x, okay, plus k. This is also one type of question. We need to find the value of k if x minus 3 is a factor of this. And what we have? We have p of x given. Okay? And we have g of x also given. Then we need to find the value of k. Since it is given that x minus 3 is a factor of this. Since it is a factor of this, that means this polynomial completely divides the other polynomial. And in this case, the remainder must be 0 because it completely divides the other polynomial. But for this, we need to find the value of a. How can we find the value of a? By simply putting x minus 3 to be 0. Or you can convert this or compare this equation with x minus a. You can also find the value of a. But you can also find the value of a by simply putting it to be 0. Then x is equal to 3. This is also known as a. Hence we get a is equal to 3. Now it will be p of 3 is equal to 0. Since we have x square minus root 2x plus k is equal to 0. So put 3 in the place of x, it will be 3 square minus root 2 into 3 plus k is equal to 0. Hence 9 minus 3 root 2 plus k is equal to 0. Hence we need to find the value of k. So this 2 term will move to the right hand side. 9 becomes minus 9. This minus becomes plus and 3 root 2. Hence the value of the constant k is equal to minus 9 plus 3 root 2. Okay. I think you are clear about what is type 3 question asking us.